So Santi, what you got going on for us today?
We are assembling the gantry for this printer that we are shipping out to Canada here today, probably. We've got a few things going on. We're doing the test fit here. All our printer kits. I mean, we machine all the parts, we make all the parts, but now we're doing the test fit, so we know that everything is in the right spot, everything is good, and you guys won't have any problems when you get the kit. So first off, I mean, things we're checking, for example, we're checking the travel. We're making sure that it travels back and forth the length of the carriage without binding up. A lot of times, if it's out of alignment right here as you get close to the end, it'll get really tough and it'll start binding up right there if it's not lined up properly. And we're making sure that it travels the entire length with that same nice smooth motion.
Oh yeah, yeah.
Just like that.
Nice.
One of the upgrades we've got going on for this printer right here, this one in particular, is, like I said, it's going to some guys in Canada. They are turning the entire printer into a heat chamber. So there's going to be more heat in this printer than any of our previous printers. So we were worried about some of the plastic parts maybe. So in the past, in our older printers, like you can see right over here, this insert right here, the lead screw nut is on the inside of this insert that attaches to this lead screw, and we've got two printed pieces on either side of here in this part with the lead screw nut on the inside. And if you come over here, I'll show you what I'm talking about. Actually, you might if you look underneath, you might be able to see here in the center the bottom of the actual lead screw nut there.
Oh yeah.
So if you come over here, I'll show you what we got. So here's one of the lead screw nuts. We're cutting those down. This one obviously hasn't been cut, so it's not gonna quite go. But we have these two 3D printed pieces that we have been using. So the lead screw nut pops into there and is cut down so it fits in here. Well, it does fit in here, but these sides are cut down so that sandwiches in there and then slides into the bottom of the C carriage down here. So now you see what we have are the actual metal replacement parts for these. So we finally got around to upgrading those. That just sits right in there. This sits right in there. And now you have that as one solid piece. Now obviously you can see where this is sticking out and isn't working there. That'll need to be cut down. This is a stock bleed screw, hasn't been modified yet. But that entire piece, now it goes, the lead screw goes there through the center, and I got it upside down. And it slides right into the C carriage here, and you can see it right there in the C carriage. And with the mounting or the bolts that hold it together, go all the way through. You can see this here on the other side.
Now the reason why we came up with this was because we had a customer that's actually going to have a heat chamber inside the printer. It's going to get up to, I think they said about 130 C. So one of the things that, one of the challenges in that build was basically it couldn't have any 3D printed parts. Now the Workhorse printer is basically all metal. Now there is some 3D printed parts on here, okay? The reason why is because you know, CNC machining gets expensive, okay? This is an older model right here. As you can see, we have some 3D printed Z-axis lead screw nut mounts. There's one right here, and there's another one. You can't really see it, but I can assure you it's back there. And you can see the 3D printed C carriage inserts, and that's pretty much it. That's two sets of parts. You have the C carriage inserts and the Z-axis lead screw nut mount. Okay, those are 3D printed. So everything else is CNC machined, or it's metal, or whatever it needs to be. So in this build, we're actually making everything out of metal. There were some challenges in making this. Basically, there's a lot of operations, and everything had to line up perfectly. If it didn't line up perfectly, there would be issues with mechanical binds, and you don't want that because bad things happen. Now, some of y'all may notice that the lead screw nut is it's made out of polymer. It's made out of IGES polymer, right? Now, the IGES polymer is pretty robust. I don't even know what kind of polymer it is. They just call it IGES polymer. But anyways, this is pretty robust stuff right here. Okay, this is good up to 165C. And they just work. You don't need any kind of lubrication. It just keeps going and going and going. We had one printer going for a couple of years, and we used the hell out of it. And I never noticed any issues with like increased backlash or any kind of issues with the lead screw nuts actually wearing out. So this is pretty robust stuff. I wouldn't even worry about it. If you're worried about the plastic wearing out after a year or so, I haven't noticed anything. So I mean, this stuff it just works. I could be an IGES fanboy. They need to send me a T-shirt.
Well, next thing, while we're sitting here looking at this printer, we're doing our test fit. For you guys and your future reference, as you are assembling these printers, there's a few things you don't want to do out of order. And that first one is, as soon as you start assembling it, the first thing you're going to think to do is go ahead and put the gantry plates and the extrusions together. Before you do that, you want to make sure you have enough of the inserts in the extrusions to go ahead and mount the linear rails on there, and that applies to both the X and the Y axis extrusions there, because if you don't put those little inserts in there and you don't have the little quick inserts, you're going to end up disassembling before you start reassembling. So you want to get that in there. You want to make sure your C carriages, both X and Y again, are attached to your linear rails before you mount these brackets on the top, because the actual screw holes are underneath these brackets. They've been machined with counterbores, so you screw those onto there before you actually put these brackets on the top of here. Other than that, it's all pretty well self-explanatory.
Now, one thing, we had the gantry assembled right here. Okay, now don't get this mixed up with. Okay, so right here we have a Workhorse frame. This gantry doesn't actually go to this frame. I mean, it could, but for this particular build, we're actually just testing a batch of parts before we ship them out. Now, one thing, if you're going to build a Workhorse printer, open source, check it out on Thingiverse. Basically, what you want to do is you have these plates right here, okay? So the gantry plates. Now, typically, the best way that I've found to actually assemble this, the quickest, is to actually take the gantry plate and go ahead and mount the gantry plate to the linear rails. Okay, so you get a gantry plate here, and you get one right here, and then you go about assembling the X-axis extrusions and the linear rails and so on, the Y-axis extrusion. Okay, so just because that we built a gantry next to a Workhorse printer frame, not to be confused with assembly, okay? Typical assembly, take the gantry plate, mount it to the linear rails, and then go about the X-axis extrusions right here.
Now, if you're having any problems squaring that up and mounting that up in there when you get there, you might want to go ahead and put the gantry plates with just the center extrusions here and get the square, and then go ahead and put that in there. But you absolutely don't want to be going and attaching all the rest of the stuff on here until you have it in the machine. You definitely want to do the majority of the assembling once it's in the machine. In particular, especially the motors, because if you look over here at our other older printer, that's the motor. The motor is hidden back inside here, so you'd have to, at an angle and all kind of finagling. It's just a huge pain in the neck. It's not worth it. Just assemble it once you got it.
Yeah, another tip too is the lead screw. Put that on last, okay? And when I say last, I'm not talking about after the printer is already done and built. Basically, if you think about the process, the first thing you want to do is get your main frame built. Okay, you get the frame built. Then what you want to do is you want to actually get the extrusions for your bed. This is the bed, and get your bed laid out. Next step is to get the gantry plates, mount those, then mount the X-axis extrusions, and you want to get your rails on and everything on there. And last, after the gantry, okay, is you want to actually put the lead screw in.
Well, before you put the lead screw in, once you have the rest of this assembled, you've got your gantry assembled. You've got your rails on here. You've got your well, you can put the motors on there. You can put the motor on here. Before you put your lead screws in, while you have your linear rails on here and you're attached to your linear rails, you want to go ahead and push it all the way to one end, as close as you can to that last bolt, and you want to go align that.
Yeah, exactly.
Back and center the rails, get everything aligned, and then go ahead and tighten down that first screw, and go ahead, slide it to the other ends. And I'm sure we have a video, or we'll have a video doing this. I'm pretty sure we've made one.
Yeah, we'll make a video.
And go ahead and square it and make sure that everything is straight and parallel and you don't have any mechanical binds before you go on and put the lead screws in there. You want that all square and all good before you put the lead screws in there.
You want to verify that you have nice slick motion before you put the lead screw on. Once you verify that everything's basically moving really smoothly, then go ahead and put the lead screw on. But like Santi said, what you want to do before you actually tighten any screws in the linear rail, what I would do is go ahead and get them started, or at least get one here and maybe one in the middle, maybe one in. But that may be a little issue because it's easier to put all your T-nuts in and then actually kind of screw it down. I mean, it doesn't have to be...
You can, as long as you're clearing the face, as long as you don't have anything sticking out above the face here, you're good. But you see, I just loosened this one up right here, and you see this how much motion you've got. So
yeah,
you've
that's
got
a lot of motion.
Play.
That is a lot of motion.
You've got that much play to work with on either side.
Yeah, so you want all the linear rails. You want to be able to move. And then you want to move the gantry or the carriage. Yeah, you want to move.
If you look, I got all this motion. The closer I get to that, the less motion that becomes. You see that moving less and less and less and less, and now it's hardly moving at all. So now I'm right there as close to it as I can get. I'm going to go ahead and tighten that back down. That's good and tight. And now we still have that nice, clean, smooth motion all the way up past it. Another thing, well, actually, I got two more really important things for this video. And the first one, well, they're both about the linear rails, but the first one, a lot of these linear rails, when you get them, see, nope, we don't have a single one down here now that's like that because we know this. Oh, here we go, here's one. So, if you see, this linear rail, you've got all your holes, but there's nothing here on the end to stop. If I can even get it out of the package, come on now. You are not working with me today, plastic. If you're not careful, this block will slide right off the linear rail, and all your bearings from inside this linear rail will go flying everywhere, and you just wasted your money on that. So, we've got a few of these with tape wrapped around them, but my favorite little trick, if you come over here, I just put a zip tie through that last hole. Man. It fits through in the slot in the extrusion, so you can install it with that installed, or with that on there.
Engineer's favorite tool: zip ties, duct tape, and WD-40.
I mean, it's kind of a temporary fix, but it keeps it.
Oh yeah, that works.
From running off the edge. I mean, that's how we store them most of the time. The next thing about the linear rails, and this is important, and we've already got these brackets over here on the top of this. So here is another C carriage, right? Once that C carriage, well, I'll just use the one I pulled out. I'll set this right across there. So you can pretend there's an extrusion under here and this is already installed. Once you put this C carriage on here, you see these counterbore holes. This is where you're going to affix the C carriage to the linear rail. Now, you have to be very cautious and you have to use very short screws because you only have the depth of the counter bore, or whatever, minus the depth of the counter bore, the thickness of that metal, and then let's see if I can show you. Nope, that one's too big. I got a small one here.
So
I got a small one here.
Basically, if your screw is too long,
you only got that much space.
Yeah, you can
if your
actually.
screw is too long, and you keep forcing it and screwing it and tightening it down into there, I think
bad things happen. Yeah, we have one.
Where is it?
I think that's it. Yeah.
This is what happens. It will bust all this out, and you'll lose all your bearings yet another way.
We had a new guy, and he did that.
That was me. Alrighty.
Alright, guys. Well, it's been fun. Also, if anybody's interested, we do custom builds and CNC machining. So if you need something machined, hit us up.
Let us know what your projects are. We're interested.
Exactly. Alright, guys. Talk to y'all later.